Hi everybody, this is Tor Storley, and I am back with another video. Okay, so continuing from our last video, we're up to number 11 here. So in this case, we're going to learn about how to join data frames. So if you look here, you can see I created a data frame here by using the PL, which is the shortcut for Polar's data frame. And here what I do is by using this dictionary object here, as you can see with these squigglies, you can create a key and a value pair. And the values can be more than one value, as you can see here. So for departments, I'm creating English, HR, and marketing. And what this really will mean is that each one of these will be a new row in this data frame. This will be the column header, and these will be the values listed in from row 1 through 3, basically. So let's see what that will look like. Control Enter. And sure enough, as you can see, English, HR, and marketing, which is these 3 rows right here. All right, so that's how you can create a quick data frame. You can also join data frames. So here, what I'm saying is, take this data frame that you can see right here, and we're going to join it on one column called department. So it's going to be joined on English, going to be English, HR is going to be joined on HR, whatever records you can find, okay? And I'm going to use an inner join. That means there's not going to be any values that has a null because they have to match. So in other words, we don't have any because every one of them has a department name. So there's not going to be an outer join or anything like that. I'm going to select these guys and let's see what that will look like. So now when I combine the two, I combine the data frame from the original data frame with this new department info where you can see right here. And now I combine the two on this column right here. And that's how you can get a joint data frame into one data frame, new data frame, I should say. You can also reshape by using pivot and unpivot. And sometimes you might see the word melt for this. Now, that's not a word I'm usually using, but I usually use pivot and unpivot. So as you can see here we're going to turn row values into column headers. And this is like a wide format. So when you go from row to column, you're doing a pivot. When you go from column to row, you're doing an unpivot. So here I'm going to select department, level, and name. And then, if you remember, these are chained commands, right? We're going to group by department and level. We're going to run an aggregation over the name by using the count function, and we're going to give it a new name called CMT. We're then going to pivot the whole thing on department, on which column, on the level, and the values are going to be the CMTs. One thing I suggest you do is, in order to understand what happens at every step, just comment out some of this stuff. So let's group by first and see what that looks like. I'm going to select these 3 and then we're going to group it. So when we run this, you can see here, okay, so that's the count. Right now the counts are vertical by department. That's this part right here. Now I might want to run the next step so I can see what happened. So I uncomment that and do the pivot. So let's see what that will look like now. Watch what happened to the CMT because those are the values. So let's run it. And notice now you got this whole thing changed, if you will, by level. And then what you can do is you can, instead of showing nulls, you can fill them with zeros. So you null, as you can see here. So let's see what that looks like. Okay, sure enough, now we get zeros. And the final thing is to sort it by department. And that's what that will look like. So that is the pivot. All right, you can also unpivot. And that will look like this. Now you're going from columns to row because we just turned it into this. So basically what we're doing is, we are taking these 3 columns and we make them vertical. And that's what you see right here. So that's how you unpivot. So that's pivot, unpivot. I don't want to spend too much time on that because that's a topic in itself. What I've done here is showing you something called a lazy frame. Lazy refers back to creating a data frame that you're not executing right up front. Meaning you create a plan for how you want to do it. So if you look here in this chaining, I'm creating a lazy data frame. So I'm telling Polars, don't do anything yet. You need an action word And the action word is this one, collect. Whenever you run this one, that's when it actually executes. Up till that, it just reads it because it doesn't do anything. So it figures out a plan, and then they optimize the plan. And basically, you could write optimize equals false here, and then you'll see a plan that is not optimized. But I want the optimized plan, and that's why I'm using this function right here. What am I saying? I want to filter everything where the salary is greater than 70,000. I want to create a new column. I want to call it salary 5% raise. Meaning I take the salary based on this filter and multiply by 5%. So it becomes 105, right? And then I'm selecting out the columns I want to see. What I want to do is I want to see what is the plan? What is it going to look like? So let me run that. And it runs, and it shows you this graphical illustration here. So if you read this, you can see it tells you that this is the execution plan optimized that it's going to use. And you can see use this with columns, and it has some internal descriptors. But basically, when it shows this pi symbol, which is this down here before the 3-8, that means that's the number of columns they're going to select. So we're going to select 3 out of the 8 columns. However, we're going to create a new one too, as you can see. But that's what this show graph does. Now, sometimes you might see something called a sigma sign, means like a sum symbol, if you will. That will indicate the filtering condition. Now, I don't see that here, so if you wrote a different query, perhaps you would see that. And then, of course, that's the show graph. And then you can also run the collect like this, right? So let's see what that will look like. Once you run the collect, it will actually execute it. And this is what the optimized execution plan looks like, the result of it, by doing this. Another thing you can do is you can also explain it, meaning you can look at the plan that it's going to use. And here it tells you how it's going to execute this data frame. You can also read and write files. So here we're going to write as a CSV file. You can use dataframe.write.csv. And here is where I'm going to put it. Then you can read it back by using polars, read CSV, right back from the one you just created. And then you can also run like a print statement. Now you have CSV, but you can also create Parquet files, which is very efficient file format because it keeps metadata in it. And then you can read by using the read Parquet, and then you can figure out how many rows there is. So when we run this first one, it creates a new file and it reads back from it. We do it again for a Parquet file, and just to prove it to you, let me just open the temp folder. There it is. There's a CSV and there's the Parquet file. This last part here deals with great tables. You have a library in R and you also have it in Python. And if you're interested in great tables and more details, please check out my previous videos that deals with great tables, and you'll get a little more deeper insight to it. But we can also use great tables with polars, and that's why the selectors and everything comes into play. I want to create a great table using the great table import, meaning this one here, okay? The styling, the great table main function, and the location. So here we're going to create a great table from a polars data frame and give it a title and a subtitle. So we create a new data frame. We select from the original data frame all these columns, and then we're going to sort them. And then we're going to pass the result by using this great table functionality, passing in the data frame to great table, and then add a couple of titles on it. So let's see what that will look like. Running it, and here you can see it looks like a very basic but nicely formatted table, as you can see. And notice here's the subtitles on that table, but it's nicely formatted, as you can see. I can also format numbers. So salary, for example, looks just like a big number. There's no formatting whatsoever. What if I don't want to see any decimals? What if I wanted to be in USD, meaning US dollars? Well, you can run this, and when you do, here is the result of the salaries, okay? So now you got a $sign, and you got a comma formatted output. So that's nice. Now, what I did was I went through the documentation. Notice you can set a lot of different flags or settings, if you will, here. And I don't even know if all of them will do anything here, but I copied it out of the original. According to what I have here, it should produce something. So Control Enter, and as you can see, it did produce. It looks pretty much the same, but it executed a bunch of this stuff here. So some of it is redundant probably because there's no decimal, so that doesn't have to be there, etc. I just want to indicate that you can do more to these functions than you normally see with 1 or 2 or 3 flags. So here you can also set colors, light to dark blue, for example, and with the salary, so the more higher the salary will get darker. So you can do that like this, and as you can see, 102 is darker than 74, for example, which is darker than 67. So you can set like a contrast to columns like this. Now, there's nothing new here as far as great tables goes. It's just that I wanted to display that you can actually use these with polars. Next thing is rename column labels for cleaner display without changing the data frame. So here you can see you rename by using this calls label. So let's see what that will look like. So instead of using name, you set employee, etc. And here you can see, so now name has become employee, department has become depth, from salary to annual salary, years has become tenure, and so on. That's another way you can do this. Now here we want to group rows under the spanner, meaning the column group, okay? You might separate column groupings, okay, by using a tab spanner. So let's see what that will look like. You have a tab header, you format currency, you create a tab spanner on compensation and tenure for these 2 columns, and then you create another one for identity where you use these guys. So you're grouping them. So here's what that will look like. So you format the currency, compensation and tenure, as you can see. You have the identity column for those 3 columns. So you group them into column groupings. You can have a custom font or background styles using this .tab style. So here you can see if it is senior, what you want to do is you want to apply a certain color. If you want it bolded, you want to find where the salary column, where the rows are at level of senior, you want to make them bold. So let's see what that will look like. And as you can see, both of these are senior, so they're bolded. And you have a certain color that you set up here as well. So you can make it very stylish. You can also add footers. You're creating a footer like this by using this .tab source note. And of course, the other stuff should be familiar by now. So hit enter. And as you can see down here, here is your footer. Okay, so you can do that as well. We can use the department column as a row group to visually separate rows by categories. So now we want to see each department separated from another department. You create some titles and subtitles. You format your currency. You create some labels like this. And then you are creating that source note. So when you run this, notice what it does. It separates English with these 3 guys, HR with these 3 guys, and so on. And then you have, of course, at the bottom here, internal HR data, right? Which is this source note, okay? All right, so that's cool. You can actually, do that kind of groupings too. Now, you can also build a polished department summary table by combining Polar's aggregations, plus the great table formatting. So here we got a bunch of columns, as you can see. We're grouping it by department. We want some aggregation, and we sort it. And then we pass it on to great tables, and then we call it department. We create some headers. We format some columns to numbers, to currency, and then we give some new labels. And then we create some spanners, like you see here. So a tab spanner for compensation, these columns. We have a tab spanner for workforce for these columns, and so on and so forth. And then we have these for the color palette you want to use. All right, so we have a footnote, and then let's see what that will look like. So that's our final output. So you have the workforce, the compensation, here's the columns. You have the footnote right here, and you have the colors, right? So that's what this code is doing. All right, so finally then in this workbook, or notebook I should say, finalize it by kind of summarizing it up, the different things we looked at here. this is a link. So if you click here, you should end up on the Great Tables page where the documentation can be found. So you can see they describe, they give a bunch of examples, and it's very good documentation. You can go to examples, you go to reference to look up each command, and you go to blogs and figure out, hey, all this stuff has been written about this stuff, and so forth. So I leave it up to you to continue your journey to learn more about Great Tables and to learn more about polars. And like I said before, if you want me to get deeper into this and do more videos on polars, let me know in your comments, okay? I appreciate it. Now, if you like my videos, give me a like and consider subscribing to my channel. It'd be fantastic. I love to hear from you. Thank you so much for watching my video, and I'll see you in the next one.